What up, everybody? Instructabeats back again here with our probability unit. Today we're talking about the probability of dependent events using a tree diagram. So let's take a chance and see what our objective is today. But first, let's do some mathcabulary. So an independent event is a type of event that we've been talking about the last couple lessons. It's when one event does not affect the probability of the second event. And we'll look at an example of this in a second. And a dependent event would be the opposite. It's when one event does affect the probability of the second event. So let's take a look at two examples to really compare these to wrap our heads around what we're talking about. So here we have an independent event versus a dependent event. And if you notice, it's very, very similar, but I'm going to highlight the key difference. This one says there's a bag with numbered tiles in it. They're numbered from 1 to 6. Angel picks a tile out randomly and then puts it back in. This one says there's a bag with numbered tiles in it. They're numbered from 1 to 6. Angel picks a tile out and then puts it to the side. He then draws out another one. So for our independent event, he's taking a tile out, but then he's putting it back in. So when he draws it out again, there's still 6, right? So here we have the bag, 1, 2, 3, 4, 5, 6 tiles that somehow look like dots. I'm not sure how that happened. And then our second event, so here's our first event. Our second event, there's still 1, 2, 3, 4, 5, 6. The first event did not affect the second one. In our dependent event, he's starting with the same bag. Okay, 1, 2, 3, 4, 5, 6 tiles that suspiciously look like dots. But then he's taking that one out and he's laying it on the side over here. So the second time he draws 1, 2, 3, 4, 5, there are now only 5 tiles in it. The second event is dependent on the first event because it was affected by it. The probability has now changed because there's less tiles to choose from. So we've been working in independent events. Today we're going to look at working with dependent events. All right, so for our we do problem, we're looking at almost the exact same question. I just changed the tiles numbered from 1 to 3 because otherwise my tree map was going to be way too big, okay? And so it says there's a bag with numbered tiles in it. They're numbered from 1 to 3. Angel picks a tile out randomly and puts it to the side. He randomly draws out another one. Make a probability model, okay, which means we need to have a sample space and we need to have the probabilities for each of the outcomes. Probability, there you go, to help answer these questions. So before we even look at the questions, let's make our probability model. And this one's going to be a little bit different. You have to think yourself through this one a little bit, but it makes a lot of sense. So for your first event, you can either draw a 1, a 2, or a 3 out, right? That makes sense. There's 3 tiles in there, so we'll make our tree map. There we go. And now in the second event, though, he's taking the 1 out. So let's start with this one. He drew a 1. He's putting that to the side. So now when he draws out the second time, he only has 2 options. He can either pick a 2 or a 3. If he drew a 2 out first, he can only pick a 1 or a 3 because the 2's no longer in there. So this is what's a little bit different from our independent compound event tree diagrams we were doing. The 3 options are not the same every time because when you draw 1 out, you're leaving it out. So if he drew a 3 first, he could either draw a 1 or a 2. Okay, so you only have a 1 or 2 left in the bag. If he drew a 1, then a 2, the only option left he would have would be 3. If he drew a 1, took it out, a 3 took it out, the only option he would have left would be a 2. Same thing here. So you're just thinking what's left in the bag. And if it helps you, you could draw the bag up here, right? And you can cross it out. So here, that's supposed to be make that a 1 so it doesn't look like 2 lines. Here he drew a 2 first and then a 1, which means he had a 3 left. He drew a 2, then a 3, which means he would have a 1 left. It's actually not bad because the tree diagrams don't get as big, but you can't just kind of rush through. You actually have to think a little bit. So 3 and a 1, that'd leave a 2. And then if he took a 3 and then took the 2, that would leave the 1 left. So now you have your outcomes. You could do 1, 2, 3. You could have done a 1, 3, 2, a 2, 1, 3, a 2, 3, 1, a 3, 1, 2, or a 3, 2, 1. So this would be our sample space, right? These are all our different possible outcomes. Now we need to think about the probability. So this is where the last lesson comes in. So for each of these were all even, right? So you had a 1/3 probability that you could pick a 1, 2, or 3. That's a uniform probability model right there. And then in the next one, you had a half of a chance for picking each of them because there's only 2 left in there, right? And then for the last one, you just had a 1 out of 1 chance. Now you don't even need to draw this out because anything times 1 is going to be itself, but just to be thorough, we want to show that you thought about the probability from each limb of your tree. So now, just like we did last lesson, to figure out the probability of drawing a 1, then a 2, then a 3, you multiply the probabilities for each step. So 1/3 times 1/2 would be 1/6. You had a 1/6 probability of drawing a 1, a 2, and then a 3. Here, you had 1/3 times 1/2, and again, that is 1/6. Here again, 1/6, 1/6, 1/6, and 1/6. So we would say this is a uniform probability model, but this is a dependent compound event because each event relied on the other one. If you drew a 2, that changed what could happen next because the 2 would be gone. You couldn't draw a 2 anymore. If you drew a 1, that changed what happened next. So you can see how this works with this tree diagram. So now let's answer the questions. What is the probability he picks a 2 first and then a 3? All right. So that would be right here. If he picked a 2 and then he picked a 3, that could only be that outcome right there. So we would say the answer to this first question is 1/6. There's a 1/6 probability that he picked a 2 and then a 3. The second question says, what is the probability he picked 2 odd numbers? Okay, so let's go back and let's look for any of these that have 2 odd numbers. And look, that one does, 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 and that one does. They all have the probability that he picked 2 odd numbers. So we would say that is a certainty. That is 100%. That is 6 out of 6. So for this one, for this answer, you could put 6 out of 6, or you could say 1 or 100%. Then the last question says, what is the probability he picked 2 3s? Well, once you picked a 3, that got out of the bag. So for that one, you would say that was 0 out of 6. There is a 0% chance for this one. It is an impossibility that he picked 2 3s because once you picked it once, you didn't put it back in the bag. So that's how we can use this tree diagram to answer these types of questions. Let's try a you-try problem. So here's our you-try problem. It says Mr. Beller has 8 boys and 7 girls in his math group. He needs 2 students to help, so he randomly picks a student to help him at the board. He then picks another one to come up as well. So the first one he picked stayed up there. What is the probability that he selected 2 boys? So go ahead and push pause, try this one out, and then push play when you're ready to check your work. So hopefully you just paused it and now you're checking your work. So your first event is that he picked either a boy or girl, right? So there are 2 options for this question, boy and girl, and they don't have the exact same probability. Okay, this is going to be a non-uniform probability model. There are 15 people total, and there are 8 boys. So there are 8 ways to pick a boy out of 15 possible outcomes. Here we had 7 out of 15, so our ratios are different. Now, this is where you need to start paying attention. Okay, this is where you need to make sure you're not getting tricked. If he picked a boy, that drops the total number to 14. Okay, so we know that for picking another boy, the probability is going to be out of 14. If he picked a boy, that means there's no longer 8, right? There's only 7. Here were your 8 boys with no legs and no arms, and he already picked one. So now you only have 7 to choose from. So to pick another boy, that probability is going to be 7/14 or 1/2. To pick a girl, though, is going to stay the same for the amount of possibility, or sorry, for the ways you could do it. But again, this is now out of 14 people. So you now have a 7/14 or a 1/2 probability of picking a girl. Let me do this in a different color over here. So then if you pick a girl first, you still have the 2 options for the second student that Mr. Beller picked. And the boys would have the same amount. They'd still have 8. Nobody got crossed out yet, but it would only be out of 14. So you could simplify that. And then if you had a girl, right, you no longer have 7 girls. You only have 6 girls left in the classroom. And there are only 14 people to choose from. So that would be 6/14. Okay, and you could simplify that to 3/7 if you wanted to, but I'm kind of running out of room. I don't want to get messy. So now all you'd have to do is you can use your calculator to do this math. You can multiply the two different probabilities to find your total probability of picking two boys. So this one right here, oh sorry, I forgot to do our sample space. We could have boy girl, we could have boy boy, we could have boy girl, we could have a girl then a boy, or we could have two girls in a row, okay? So you're only looking for the probability of this one right here. So you don't even have to do the math for the rest of the tree diagram. You can get your calculator out, and you know your numerator is going to be 56, and then 14 times 15 is 210. So the probability, if he did this 210 times, we would expect him to pick two boys 56 out of those times. And you could even simplify that if you wanted to, and you could say your answer was 28 out of 105. So that's how you use your tree diagram in a non-uniform, dependent type of way. Let's try the challenge zone. All right, so this one says, without drawing a tree map, so no vision model, try to solve the following question. There are 30 Instructabeats songs on YouTube. 4 of them were written by Yolanda. If 4 songs were picked randomly without replacement, that means once you picked a song, it did not go back in, right? So now this is a dependent compound event, okay? What are the chances that all 4 songs picked were written by Yolanda? So go back and look at how we did the other ones with the tree maps. Try to see what you did mathematically, and that's your goal. Solve this mathematically without the visual model. So hopefully you just tried it, and now you're checking your answer. Maybe you have no clue, and that's okay too. So the first thing I'm going to do is I'm going to start with the probability that in the first event, okay, so in event 1, if you will, there we go, a song written by Yolanda was picked out, right? So that would be 4 out of 30. And you could simplify that if you wanted to 2/15, but I'm not going to because it's just going to help me show what we're doing. That means in event 2, there are now only 29 total songs. And again, we wanted to pick all 4 in a row, right? So we want an Instructabeats song, Instructabeats song, Instructabeats song, Instructabeats song. So here are my 4 Instructabeats songs, right? They're all represented by an I. In the first event, we picked one. Now we only have 29 total songs, but we only have 3 Instructabeats songs left. So for our second event, to pick a Instructabeats song would be what you would have a probability of 3 29s, okay? Then if you kept going, we now only have 28 songs, and guess what? You just picked out another Instructabeats song. So now you only have 2 Instructabeats songs left, right? And then for event number 4, picking another one out, again, now we only have 27 total songs, and you just picked out an Instructabeats song, so there's only 1 Instructabeats song left. So for the 4th event, if you pick 27 different times, we're expecting you to pick the Instructabeats song only once, right? That's what probability is. It's telling your chances of an event happening. So the probability of picking, and I'll just do I for the 4 Instructabeats songs. So probability of picking the 4 I's in a row means we need to multiply, because if we were doing a tree limb, these would have all been different events. You would have kind of multiplied your way down the tree limb to figure this out. So if you did 657,720 trials, we would only expect you to pick the 4 Instructabeats song written by Yolanda in a row only 24 of those times. So we would say that is very, 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 very unlikely. Thank you so much for checking us out today. We appreciate you watching Instructabeats. We know there's lots of different options out there. We would love for you to subscribe and join our Instructabeats family. You can follow us on all our social media accounts. Again, thank you so much. Instructabeats out.